am Deboline Ghosh, Assistant Professor of Haldia Institute of Technology of Department of Information Technology. Now, I am going to present on the topic called Minimum Spanning Tree Algorithms. So, what is a spanning tree? A spanning tree is a type of tree which is formed with the minimum weights and which does not form a cycle. Now, we can consider that a spanning tree has the minimum weight among all the possible spanning trees. So, the question will come that what are the properties of minimum spanning tree? So, the properties of minimum spanning tree lies in the fact that number one is the unique for distinct weights. So, if all the edge weights in the graph are distinct, the MST is unique. Now, we can also tell that if there are duplicate edge weights, there may be multiple MSTs with the same total weight. There are also number two, that number of edges. So the MST of a graph with V vertices always contain exactly V minus 1 edges. And property number three is that graph must be connected. And MST exists if and only if the graph is connected. All vertices are reachable from any other vertex. Now we can see the diagram of a minimum spanning tree for a directed graph. So in the diagram, how many vertices are there? There are total 3 vertices. What are they? Vertex 1, vertex 2 and vertex 3. Now what are the weights? 2, 3 and 10. From this graph, we are just forming one spanning tree. What are the vertices now? 3, but the number of edges, as I told, that V minus 1. V is the total number of vertices minus 1. So here 3 minus 1, that is 2. So 2 is the number of edges and 3 is the number of vertices present in the minimum spanning tree. And here the number of vertices is 1, 2 and 3 and the weights are 2 and 3. And this is directed, means one vertex is connected with another vertex. That's why arrows are there. So the main topic and the main problem of this presentation is that what are the two types of minimum spanning tree algorithms. One is the Kruskal algorithm and second one is the Prim's algorithm. Here, Kruskal's algorithm, there are total 3 steps I have written for consideration. So, how can we determine whether an algorithm is Kruskal? What are the steps to solve Kruskal's algorithm? Step 1, we have to first arrange all the edges of the graph in non-decreasing or increasing order in terms of weight. So, increasing order of weight, we have to arrange the edges of the graph. Step 2 is that we have from here, we have to pick the smallest edge and we have to check if it forms a cycle with the spanning tree formed so far. If the cycle is not formed, then only we can include this edge. Else, we have to discard. So, if and only if the cycle is not formed, we have to maintain that. If the cycle is formed, we cannot take that smallest edge. Now, what is the third step of Kruskal's algorithm? That we have to repeat this step until there are V minus 1 edges in the spanning tree, where V is the total number of graph vertices present in the graph. Now, here we are following that one diagram of a graph is there. So, how many edges are there? Total 14 edges are there and total 9 vertex are there. But from this graph, if we want to construct a minimum spanning tree, we have to just consider that total number of vertices if 9, then we have to take 9 minus 1, that is 8 edges from the graph. And we have to arrange the edges in terms of increasing order of the graph. Now, look at the table. Here, weights are there and its corresponding source is there and its destination. First, we have to start with the minimum weight. So, what is the minimum weight? 1. And from 1 is connecting from which to which? That is from source to destination. So, in the first row, what is the source? 7 and what is the destination? 6. In the second row, what is the minimum weight? 2 and it is connecting from 8 and destination is 2. What is the another second lowest weight? Again, it's 2 and it is also connecting from 6 to 5. Then we are considering the next lowest weight. Next lowest weight is row number 4, that is 0 and 1. So, from 0 and 1, what is the lowest weight? 4. Then again there is another weight called 4 which is connecting from 2 to 5. Then the next possible lowest weight is 6, it is connecting from 8 to 6. Then the next lowest weight is 7 which is connecting from 2 to 3. Then the another next in, lowest weight is 7 which is connecting from 7 to 8. Then another lowest weight is 8 which is connecting from 0 to 7. Again there is another weight that is 8 which is connecting from 1 to 2. Again 9, 10, 11 and so on. That is 14 is the highest weight given which is connecting from source 3 and destination 5. So this is the tabular structure which can be generated from the graph. Now from the graph we have just taken the vertices step by step. Now coming to step number 1, what is the source given? 7 and destination 6, and what is the minimum weight? That is 1. So we have constructed. Then what is step 2? That from step 2 the minimum weight we have taken is 2, and what is the source? 8 and destination 2. What is the third step? We have taken source 6 and destination 5. Again the minimum weight is 2. In the step 4, what is the minimum weight? That is 4, and it is connecting from 1 to from 6 to 5, and from 0 to 1, that is 4. Now here step number 5, we are just adding the age 2 to 5, and what is the weight? That is 4. In step 6 we are adding the age 2 to 3, and why? Because from 8 to 6 we can't add, because if we add from 8 to 6 it forms a cycle which is not considering constructing a minimum spanning tree. So we have taken 2 to 3, and what is the minimum weight? 7. Then in step number 7 we have taken from 0 to 7, the minimum weight taken is 8. Then from 3 to 4, the minimum weight taken is 9. Now coming to the pseudocode of Kruskal algorithm. First, we have taken the name of the algorithm called Kruskal, and what is the function? We have taken as graph. Then we have initialized MST as an empty set. Then we are sorting all the edges in by their weight in non-decreasing order. Then we are creating a disjoint set for all vertices. That means no connection will be there. Then for each edge, like for that is called U and V, where U is the source and V is the destination. In the sorted edge list, we are finding that if find U not equals to find V, then we are adding one edge UV to MST and union the sets of U and V. So suppose U is the source and V is the destination. So we will construct one edge from U to V, and we have to make sure that it is the smallest edge taken and it does not form a cycle. Here U is the set to which vertex U belongs, and union of UV is the merge the sets of U and V. Now coming to Prim's algorithm. Here step 1 is first we have to determine one arbitrary vertex as the starting vertex of the MST. Step 2 is we have to follow the steps so that it iterates through all the vertices, and so that all the vertices are included and no other vertices are left to be considered. Then step number 3, we have to find the edges connecting any tree vertex with the fringe vertices. Step 4, we have to find the minimum among these edges. Step 5, we have to add the chosen edge to the MST if it does not form any cycle. Step 6, return the MST and exist. Now, let us look at the diagram. Here, consider that the starting vertex. So here, what is the starting vertex? 0. From 0, what is the adjacent vertex? 1 and adjacent vertex 7. So we will consider the weights from 0 to 1 and 0 to 7, that is 4 and 8. Now coming to diagram 4. So here in diagram 4, we are taking 0 to 1 and 0 to 7, the two adjacent vertices of the starting vertex of 0, and what are the weights? 4 and 8. Now in the next diagram, what is the last destination we have achieved? That is called 7. So from 7, we have taken the adjacent vertex called 6. What is the minimum weight? 1. Why we have not taken from 7 to 8? Because the weight is more than 1. So we will consider from 7 to 6. That is the weight is 1. Now, from again in the next diagram, in the second diagram, we will consider that from 6 is the last destination. Now the next destination to be achieved is 5. And what is the weight taken? 2. Then again from 5 to 2, that is called 4. And then from 2 to 8, that is called 2. Now from uh, 2 to 3, the weight we are taking as 7. And from 3 to 4, we are taking the last highest weight, that is called 9, to form the spanning tree. So 9 is the highest weight we have taken to construct the spanning tree, not more than that. Now, when we are considering the final structure of the MST, with the weight of the edges of the MST, calculation is done and we will achieve the minimum weights, that is 4 plus 8 plus 1 plus 2 plus 4 plus 2 plus 7 plus 9, that is 37. So 37 is the total weight of the edges of the MST. Now coming to the pseudocode of Prim's algorithm. Here the name of the algorithm is Prim, and here we will first initialize an empty set to hold the vertices in the minimum spanning tree. Then we will consider MST equals to empty set. Then we will select the first vertex to start the tree, and the start vertex equals to first vertex in the graph. Then we will initialize the set of edges to consider. Then we will iterate until all the vertices are in the minimum spanning tree. Here, to find the minimum edge in the set of edges, we will consider the minimum edge and minimum weight. To find the minimum edge and edges. Now, we will first add the vertex to the minimum spanning tree. So for adding the vertex to the minimum spanning tree, we will just write mst.add and within bracket min edge. Then we will add the edges connected to the vertex to the set of edges to consider. So for all the edges in edges connected to min edge, if edge is not in mst, edges.add edge. Then we will remove the minimum edge from the set of edges to consider, edges.remove min edge. Then we will return the minimum spanning tree as an array, return MST as an array. Now coming to the time complexity of Kruskal's algorithm. So the time complexity of Kruskal's algorithm is O E log E or O E log V, where E is the number of edges and V is the number of vertices in the graph. Now time complexity of Prim's algorithm is O V plus E log V, where V is the number of vertices and E is the number of edges. So these two are the time complexity of Kruskal's algorithm and Prim's algorithm. Now, we will come to the differences between Kruskal's and Prim's algorithm. So, coming to the first point, look at the first row. So, Kruskal's algorithm, what is it? That this algorithm begins to construct the shortest spanning tree from the vertex having the lowest weight in the graph. So, we will always consider the lowest weight in the graph. And in the Prim's, this algorithm begins to construct the shortest spanning tree from any vertex in the graph. It is not that we have to only consider the lowest. We have to consider any vertex in the graph. Whatever the adjacent vertex will contain the lowest weight, that edge we will consider. Now in the second point, we will tell that it crosses one node only one time. And in Prim's, to obtain the minimum distance, it traverses one node more than one time. So this is the basic difference. Third point is that the time complexity of Kruskal's algorithm is O E log V and the time complexity of Prim's algorithm is O V2. Fourth point, Kruskal's algorithm may have disconnected graphs and in Prim's algorithm all the graph elements must be connected. Fifth, when it comes to sparse graphs, Kruskal's algorithm runs faster, whereas the Prim's algorithm runs faster on dense graphs. Sixth, it prefers the heap data structure, whereas the Prim's algorithm prefers least data structure. Now, from this difference, once again I am giving you a quick recap that in Kruskal's algorithm, we will first construct the graph using only the minimum edges. It can be disconnected graph. It is not like that the graph should be connected from the beginning. Not like that. It can be disconnected graph in Kruskal's. After all the minimum edges taken, then only one connection can be formed but without forming a cycle. But in Prim's algorithm, what happens? That here we have to first consider that we have to start with any arbitrary starting vertex. From the arbitrary starting vertex, we will first take the two adjacent vertices from the starting vertex. After taking the adjacent vertex, then we will consider the last adjacent vertex what we have taken. We will again find another adjacent vertex of that which have the least weight. Again, we have to find another adjacent vertex which have the least weight. So from the beginning only, taking the adjacent edge one each at a time, the graph is directed from the beginning, but it will not also not form a cycle. So this is the basic difference. Kruskal's algorithm, the graphs can be disconnected from the beginning, but in Prim's, the graphs will not be disconnected from the beginning. But in both the cases, cycle must not be formed. So this is one basic example of minimum spanning tree algorithm. So that's all for today. Have a good day. Thank you. I hope my lecture is clear. Thank you.